So we are in Statistical Rethinking, second edition, chapter 9, and we're looking at questions 9E6 and 9E7 together because they deal with very similar topics. So we're supposed to sketch a good trace plot or a trace plot for a good Markov chain that is effectively sampling from the posterior, and declare what's good about it, and then also show a bad one and what's bad about it. And then we're supposed to do the same thing for a Trank plot or a trace rank plot. So we're just going to tackle that all together here. So first, let me talk about what the difference is between trace plots and Trank plots or trace rank plots. Okay. So here I have two Trank plots on the left, and then two trace plots on the right part. Okay, and the top one is unhealthy chains, and the bottom one is healthy chains. So, but let's just look at what these are. So, a trace plot traces each iteration of each chain. So you see several different colored lines, and this is representing different chains of our Markov chain Monte Carlo model, and so they're plotting from left to right as we go through the sequence of iterations, and then they raise or they go to the height or depth of the parameter value, right? So as I go here, so on the whatever iteration this is on the x-axis, it raises up to the height of whatever parameter value that particular sample happened to be. Okay, and so it goes along, right? Now on the Trank plot, now I've flipped it up on its end here just to show that that its x-axis is the parameter value, right? Whereas in the trace plot that was the y-axis, and now the x-axis, if you tilt your head to the left here, the x-axis is the frequency at which each of the parameter values are being visited, or at least every bin of the parameter values are being arrived at during the running of your model, right? So there is no sequence, there is no time component in the Trank plot, in the trace rank plot. Okay, so that's the difference between the two, and you can kind of see how they relate. Okay, so I have a feeling that maybe these, doesn't matter. Okay, so anyway, so what is a healthy chain? So let's go down here and look at these healthy chains, and there's a few criteria that make it a healthy chain. But if we could, I think that either in the book or it's said elsewhere that a good-looking set of chains looks like a fuzzy caterpillar. Okay, and so what that is getting at is, one, there should be visually kind of a central band that every chain should be kind of around a central horizontal band. Okay, and so that is so that's called stationarity. Okay, so in other words, kind of the central tendency of a band doesn't really change around a lot. Okay, it's not going up and down in the trace plot. Okay, and the different chains should have that same central band, right? They should all be around that same central band here. All right, and so that's called convergence. And then similarly, all together, including their deviations and their behavior around the central band, those should all of the chains should be well mixed, right? So it should be kind of a mess all the way around, right? They should all be mixed very, very well. Okay, so this is an example of a healthy set of chains. Okay, and you see how that's not the case here. All right, so it looks like there is probably some kind of stationarity. It looks like there is more or less a central band. Okay, and maybe even convergence. But notice that there isn't good mixing, right? The chains are not, as they deviate from their central bands, they're doing very different things. So in other words, it seems that they are exploring very different parts of parameter space here. Okay. So now if we go now to the healthy, the corresponding healthy Trank plot, okay. So remember, this is just a histogram. I mean, it's kind of a histogram. It's not quite, but close enough. It's overlaid histograms. And basically, the histograms should look very, very similar. So they should be well mixed. So that does not mean that they should completely overlay one another, right? But you notice here, for instance, it looks like there's a region of high probability in posterior space because we have 3 chains here, and they're all kind of peaking around the same area, okay? And similarly, here's an area of low frequency, of low probability and parameter space, okay? Now, if you look at the corresponding unhealthy Trank plot, okay, you notice that the histograms look very, very different, right? And again, this is indicative of them visiting different parameter space, right? So if we look at this blue one, in this area of parameter space, kind of, I guess, low values, it's frequently visiting that area, okay? Whereas the gray and the black chains are not visiting that area very frequently, okay? But if I go to kind of this central band, then that pattern is more or less flipped. So again, these chains are not exploring the same area of parameter space. So anyway, so there's trace plots and Trank plots, healthy and unhealthy, and how they relate.